everybody at home. Here is your warm-up. Use the Pythagorean theorem to find the missing side lengths of the right triangles below. You're going to want to pause the video because we're ready to hit this, and let's make it happen. All right, everybody, let's do it. Can I get you up here in 5, 4, 3, 2, 1. Here we go. So let's go ahead and grab this. Copy that. Okay, we got to open it. In fact, here's how it's going to work. You ready for this? Okay. Odds. Your job is you're on the PDF annotator, okay? Evens, you're on the calculator. Does that make sense? Okay, so odds, here we go. PDF annotator. Evens. TI Smart View, TM Emulator software for the TI-30X/TI-34 Multi-View. TM Calculators, Texas Instruments, validating software license, ... Woo woo! Well, that was beautiful. All right, that was beautiful. Hey, you know what? If that wasn't worth the point, I don't know what is. Look at that. Okay, let's do it here, guys. So, grab that, make a new document. Go ahead and paste that in there. See, that was the computer gods showing us their approval by making those match up simultaneously like that. I'm a big fan of that. Okay, let's see here. Betsy, how am I going to find the unknown length of this right triangle here? This first one. Uh-huh. Right. You find the area of the squares on there. So that's 576 kilometers squared. And that's for the square that we make here. And then that's plus the 49 kilometers squared. And that would be this guy right here. And what does that equal when you add those up? 625 kilometers squared, which is the area of the square on the hypotenuse there. Great. So how do I find, excuse me, that side length? Yeah, the square root of 625, which if memory serves is actually kind of a nice number. Is it 25? Yeah, so that's 25. So that's 25 kilometers. How many of us were able to get that guy right there? Perfect. Let's look at this next one here. Let's see if I can get a little bit of help on that one from, that's going to be Hugh. Hugh, what am I going to do to find the missing leg length right here? Yeah, so 16 squared minus 15 squared. And the reason is because the area of this square is equal to the area of this square plus the area of this square. So if I want to know the area here, I got to subtract them. So that's 256 minus 1, minus 225? Is that correct? 256 minus 225, I think. That's 31. So that means that the area here is 31 centimeters squared. Take the square root of it. And the exact length is the square root of 31 centimeters. Which is approximately 5.568. It's about 5.568. Which again, it all depends on what you're after. Like the approximate's fine. Like if this is an earbud and you're trying to talk about its dimensions, do you think that's a good enough number there? Also, this thing's huge. Don't put this in your ear. This is a very dangerous earbud. But if this is like an appendix and you're telling a robot how much to cut out, what number do you think you want to give it? You want to give it the square root of 31. You want to be like, yeah, cut out the square root of 31 centimeters, please. And the robot will be like, I can't do that, right? And it'll cut out exactly the right amount. Or it'll round it to something that will be okay. Like, I don't know, when it comes to like cutting things out of my body, I don't know if the nearest 1,000th centimeter makes me feel happy. Right? It's like we rounded to the nearest whole number. Yeah, no. It's the 130th day of school, guys. You know that since 130 can be written as these things are weird. 2 to the 7th plus 2, or as 5 to the 3rd plus 5. It's what we call doubly strictly absurd. I'm still trying to, I didn't have time to look that up and like see if I could find a hard-nosed definition for strictly absurd, but I'm assuming strictly absurd numbers are going to be numbers that are like 3 to the 3rd plus 3, or like 4 to the 5th plus 4. I'm not sure. Happy Ken Day. Yay! I'm just Ken. All right. Let's see here. What's our first essential question? And I would love to get that from Andy. Yeah, let's see here. So, what if right triangles have irrational side lengths? Can we go ahead and write that down? What if right triangles have irrational side lengths? Okay. And then what's our second essential question? And I would love to get that one from, that'll be Thomas. How can the Pythagorean theorem help me find the length of line segments on a grid? And last but not least, what's our last essential question? And I would love to get that one from, let's see here, that's going to be, nope. There we go. Ross, what's our last essential question there? Yeah, do my canvas and focus grades match up? So what we're going to do, guys, is near the end of the, well, once we get to the part where you're working on your self-assessments, we're going to go ahead and we're going to talk to each other. We're going to look up our focus grades, our canvas grades, and make sure they look right. Like you look at your skill check grades on focus and canvas and make sure they match, because if they don't, you got to send me a little message, and that way I can make sure that everything's the way it is, because I'm posting grades tomorrow, okay? Okay, so let's get to it, guys. Underneath all this, got a pencil?
Absolutely.
Today's topic is the revenge of Hippasus. Uh-huh. No, so Hippasus was a member of the freaky cult, but he was the guy who discovered that irrational numbers are in fact irrational. Pythagoras believed that there was that no matter what number you're talking about, you could write it as a fraction of whole numbers. And this is we hadn't found the right one for the square root of 2. And basically, what happened was, I don't know, I can try to recreate it. You can put your pencils down. Let me see if I can recreate what Hippasus said. He said, okay, suppose A and B are a reduced fraction, and that's equal to the square root of 2, right? Are you guys okay with that? Like A over B, A is an integer, B is an integer, and it's equal to the square root of 2. It's reduced, so do A and B have any factors in common? Well, if we have a reduced, so what Pythagoras said is that that all numbers should have a fraction of integers. Guys, that's enough. Can't keep your hands to yourself. All numbers should have a fraction of integers. Yeah, you guys. A fraction of integers that match. That if you divide this by this, you're going to get the square root of 2. Now, if that's reduced, if I have a reduced fraction, do reduced fractions have any factors in common? No, right? Because if they did, I would reduce it further, right? So Hippasus squared that and got a squared over b squared equals 2. That means a squared divided by b squared is 2, which means, would these have to have some factors in common to make that happen? Like if I said this number divided by that number is 2, could it be that I wrote a fraction, an unreducible fraction? No. Yeah, I couldn't write an unreducible fraction. So he showed that these have to, even if you say these have no factors in common, then they have to have factors in common, which is impossible. And it got him killed. But on a happy note, guys, we're going to go ahead and cheese off Pythagoras today by putting irrational numbers in his favorite stuff, right triangle. So, got a pencil? Here we go. Draw a right triangle for me. Now, I'm going to show you something that at first you might think looks very strange and maybe difficult, but I'm here to tell you guys it's not as bad as it looks, okay? It's not as bad as it looks. And let's see here. This is going to be 5 centimeters. This is the square root of 11 centimeters. What's this? What do you guys think about that? I've just put an irrational number in for the leg of a right triangle. How do you think that is going to work? Give it a try and teach. Go ahead and talk to your partners, guys. Hooray. Just one no name? Perfect. Thanks, Stella. That's all I got for you. Oh. You should get a nice number. If you're doing it right, you should get a nice number. Okay, talk about your processes. What'd you guys do? All right. Can I get you guys back up here in 5, 4, 3, 2, 1? Thomas, what did you get for this? 6 is the correct answer. 6 is the correct answer. Can I show you? I had some people in the past, not this time, but in the past they've said, I got something close to 6. And here's what they did. So they did square root of 11. 3.317 squared plus 5 squared. Take the square root of that. They said, I got something close to 6, but it was a nasty number. Can someone tell me what happened to this person? What happened to this person? Ellie. Yeah. And the truth is, guys, how many people looked at this initially and thought that was going to be harder, but then thought about it and realized that's actually easier? Yeah, because if I take something that's got the 5 centimeters, that guy's got an area of 25 centimeters squared. And if this is the square root of 11 centimeters, then what's the square root of 11 times itself?
11.
It's 11, right? Because the square root says, what's this number times itself? So if you say, what the number that, if you multiply it by itself, you get 11. If you multiply it by itself, what do you think you get? 11. Add those together, and you get 36 centimeters squared for this guy. And the square root of that is 6 centimeters. How many of us got that or see how we got that and aren't too concerned? You guys doing okay there? Great, very good. I get a complaint a lot. A lot of times people are like, Mr. Petersen, you're normally not a very good artist, but this really takes the cake. This triangle is super duper not drawn to scale. What do you guys think? Do you guys think, here, give me a thumbs up if you're like, that is a perfect scale model, and like, I don't know, somebody take a picture and make a poster. And put a big thumbs down if you agree. Like, that is a terrible, terrible picture about what's going on. Okay. What? Well, thank you. I appreciate those of you putting me around here, because I don't think it's perfect, right? Like, there's no way that if I actually took out, like, if I did 5 divided by the square root of 11, I really got like the difference there. But I definitely didn't do that bad. Can someone tell me why they think why do you think someone would think my picture's way off? Why do you think someone would think my picture's way off, Ross?
They would think that that side is 11,
Yes.
and actually 3 point whatever.
Exactly. It's the square root of 11. So if this is 5, is it kind of reasonable that that might be 3? Maybe not. But yeah, that's why I think my favorite was like here, right? Because this should be a little bit more than half the distance of this guy. But a lot of people are like, that should be much longer. Like, it should be like twice as long as 5, but that's not the case. Let's do another one. I'm going to do 3 of these, and then we're going to look at one other thing, and then we're going to work on our Chromebooks. Go ahead, and got a pencil? Yep. This is the square root of 30 centimeters. This is the square root of 6 centimeters. What is this? Teach, teach. Now, this one's not a nice number. I would love the exact and the approximate, please. That'll do it. That will do it.
It's 2 root 6.
Well, oh no! This answer's been redacted. Oh, did it? Is that it for 25? Hang on. Yes? That's because you really need it, I guess. All right. Can I get you in 5, 4, 3, 2, 1? Guys, you know what answer I get a lot for this? 6.
What?
Can someone explain how they think somebody might have gotten 6? Ani, how do you think someone got 6?
A guy made this mistake just now.
Okay.
So basically, since they take the square root of 6, and so just like a squared plus b squared is
Uh-huh.
they thought both of them were
Okay.
those were the legs.
Right. Yes. And so they added them instead of subtracting. Very good. But that's not the case. So what is the real what's the real length there, Ani?
So the real answer is 2 root 6 because you have to do 3 minus 6. That would give you 24. Then you need square root of 25. That would give you 2 root 6.
Yeah, and do you have the approximate for that as well?
Yeah, that's 4.899.
Awesome. How many of us got 2 root 6 or about 4.899 for that? Let's see, because yeah, what you do is the square root of 30 squared, that's 30. The square root of 6 squared, that's 6. Take them away, that's 24. And that is indeed, when you take the square root of 24, 2 root 6, which is about 4.8989. Yeah, so that 8 gets cut off there and rounded to the nearest thousandth, and then that's 9. Very good. How many of us are feeling pretty good about these? You guys doing okay? Cool, cool, cool. I got one more of these for you.
Is it a wave?
No.
What's a wave?
I don't know. So I'm going to tell you that these two side lengths are the same. And that this is 4 square roots of 7 miles long. Can you tell me the exact and approximate, if necessary, length of those two? Give it a shot. Think it over. Oh, yes. Yes. Give it a shot. Think it over and teach. Yeah. There you go. If you're going to do it algebraically, for sure. Although, don't forget to square that side as well, right? So you have to make sure that side is also squared. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Maya, how did you do this? Uh-huh. So about 1 point, this is about 1.627. Uh-huh. Wait, oh wait, hold on. That seems low. That seems low. Let's see, 4 square roots of 7. Do you know what I think? I think you might have accidentally put in the fourth root of 7. That sounds about right. But I'll tell you this right now, Maya. This is actually going to run into the same problem that we had. Remember I said there were people who are like, it's like really close to 6, but not quite there? If we round this, that's not necessarily going to help us. So, well, it will, but not in the way that we want it to. So what can do, like, what is it you want to do with that number? Now that we have it, what do you want to do with it? So that's perfect. What I'm going to say, Maya, is let's do that, but not even round it. There's a few ways you can do it. You can just do it manually, like 4 square roots of 7 times 4 square roots of 7. You can do it like that. Or you can put it in parentheses, 4 square roots of 7, oops, squared. Either one of those is just fine. Honestly, I kind of do these by hand myself. When I think 4 square roots of 7 times 4 square roots of 7, I think 4 times 4 is 16. Root 7 times root 7 is 7. It's 16 times 7, which is 112. There's a few ways you could do it. So that means that the area here is 112 miles squared. What am I going to do with that? Oh, so we've actually already squared it. That's okay, Maya. Yeah, I know these are a little tricky. These are a little tricky. So we've already squared that, and now we get this guy here. So what are we going to do with the 112? Let her think. Yeah, because we know that they both have even amounts. So each of these has 56, excuse me, not 66. 56 miles squared. And what am I going to do with that number? Yep. And now what do I do with that to find the unknown number? Yeah, take the square root of 56, which, I don't know, does that reduce? Square root of 56. Yeah, 2 root 14. 2 square roots of 14. So the exact length is 2 root 14 miles, but the approximate is 7.483, about 7.483. Does that make sense, Maya? Perfect. How many of us got that or see how we got that in our tool arm? That's a little less than I was hoping. That was about half. Before I forget, today we do need our pencil, our Chromebook, our math notebook, and our calculator. No, I didn't put calculator. Calculator twice. I'm okay. I did all the right things. There is a self-assessment that we're going to work on. We might change it over so there's only one of them, but we'll see. You know what else I didn't do? I didn't do Jeopardy. I forgot to do Jeopardy with you guys and the Pictionary. So, fast food chain by founding year, first location, current menu item. July 23rd, 1954, Miami, Florida. Barbecue Bacon Whopper Jr. That is indeed Burger King. And then state flags, that's Alaska. That's Alaska. Somebody tell Mr. Doherty. All right. Let's do one more of these. Let's do one more of these. Okay. Let me draw a right triangle here. This distance here is going to be 2 square roots of 5 centimeters. And this distance here is going to be 3 square roots of 10 centimeters. And I want to know that distance right there. See what you guys can do and teach. The only thing I'm going to do is point that out for a minute. I'll be back. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1?
Oh boy.
That's the chicken. What? Okay. Back, 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 back. Oh, back, 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 back.
So I realized something is that so on this one earlier, this side length is 1/5 and so
Ah.
is this.
Ah.
And I just realized with like these kinds of right triangles, this side length is almost like always one less than the other.
Hmm.
Like
Yeah.
this isn't exactly, but it's
Right.
really close.
What about this one?
That one I don't know,
That
because
one's a
that
little
one's
different.
different.
Yeah, that one's
But
a little
like
different.
this kind.
Yeah. So that I just had to answer that question. Also, there's no. I know, but I also have to answer a question. I also say, will you guys also? I almost forgot to say. Can I get you in 5, 4, 3, 2, 1? Before I go back into the chicken mode, two things. Make sure if you'll take a moment and look at your canvas and your focus and make sure there's no surprises. Like if there is a grade on focus that is lower than your grade on canvas, please let me know. If there's a grade on canvas lower than on focus, then I guess just probably right? um, but also, will you double check and make sure? How many of you did not get a chance to sign up for enrichment yesterday? Okay, on my front page, there is an enrichment sign up. It is the new one. Please do that first so that you are signed up for an enrichment and don't get pulled somewhere you don't want to go. Go ahead, guys. Let's give that a try. And T.